Namaste, I am Rohan, and in this video we will learn about Harrod growth model and we will learn the mathematical derivation of this model. So we have two approaches for this. One is differential equation approach and other is difference equation. First of all, we will deal with the difference equation. For this, we must have a few number of assumptions. That is, one is saving is linear function of income. This is saving s equals to s. I write y. I write yt. This is equation 1. And equation 2 is labor grows at n rate. Labor means the labor force grows at n rate. Mathematically, it is 1 by L dl by dt equals to n. I will do, and number third is investment is the function of change in income. So this is investment I equals to, I write v means some coefficient. It is the coefficient, and yt minus 1. This v is ACCLERA, acceleration coefficient. I write it as 3. So these are the three equations we need, and we will use equation 1 and equation 3 only for this purpose. So in equilibrium, saving cost investment. It means that saving is in this part. So SYT equals to V times investment is YT minus 1, or saving YT equals to V times, we will open the bracket, YT minus 1, or I will simply bring this term as if I will write 0 equals to V yt minus s yt minus v yt minus 1. I have dragged this term to right, so I will take common minus s yt minus v yt minus 1, or I will write yt minus v yt minus 1 equals to 0, or I will divide this whole term by minus s and same term in the right side also, or it's yt minus v by v minus s, yt minus 1 equals to 0. So for the purpose of simplicity, I will write yt plus 1 minus v minus s, yt equals to 0. I write it as 4. This is equation 4, and we can see that equation 4 is difference equation, first order homogeneous difference equation. So we can solve it. We can now we will find its complementary function. complementary function. For it we will let yt equals to a bt when it is not equal to 0, yt plus 1 equals to a bt plus 1. So we will replace these two values in our equation 4 in this equation. So it's a bt plus 1 minus v by v minus s. A bt is equals to 0. A bt, I will take it common. First of all, I will break this term, minus v by v minus s. A bt equals to 0, or I will take common a bt. It's b minus v by v minus s equals to 0. Since a bt is not equal to 0, from this condition it's equal to 0, and it's b equals to v by v minus s. Therefore yt equals to a v by v minus s to the power t is the general solution. This is the general solution, and for our other solution, that is for our definite solution, we will find the which value at time equals to 0. When t equals to 0, our previous solution is yt equals to a v by v minus s to the power t, and when t equals 0, a it's v minus s to the power 0 equals to a equals to y0. So our definite solution is yt equals to y0 v by v minus s to the power t is the definite solution. What is time path analysis? Time path analysis, if it's case 1, if v is greater than s, then whole v by v minus s is greater than 0. So the time path is divergent but non-oscillatory. OSCI, sorry, this spelling is incorrect. OSCILLATORY. Number 2, if v equals to s, then v by v minus s equals to infinity. So here is no any solution. Its time path is divergent, non-divergent. And number 3, if v is less than s, then v by v minus s is less than 0. So the time path is divergent oscillatory. So from here, from these three analyses, we have found that the time path is divergent in all these cases. So the equilibrium is not stable